All right, today we're going to take notes, and today we're going to move on from exponent rules to talking about negative exponents. And so we've done a little bit of talk about the product, power, and quotient rule. And we have notes on those. But today I want to talk about negative exponents. So we are going to do a quick review. We're going to combine a few properties together for this first problem. So go ahead and write down here number 1. And we're going to make this problem x to the 6th over x to the 6th times by x to the 8th. So go and write that down. X to the 6th over x to the 6th times x to the 8th. Now within this problem, we have a fraction, which means anytime you see a fraction, you should immediately think quotient rule. And we also have a multiplying sign. Whenever you have a multiplying sign, you should immediately think product rule, add exponents. So quotient rule, subtract exponents, product rule, add exponents. So let's continue on here. Let's focus on these two, and we're just going to use product rule, which says if we're multiplying numbers with the same base, we can add their exponents. So x to the 6th times x to the 8th, we're going to add those together, and I get x to the 14, x to the power of 14. I didn't do anything to the top. There's nothing to combine with it on top, so I'm going to leave it x to the 6th. So now that you get here, this was product rule in the denominator in the bottom of the fraction. But now I have just the fraction here, no operations to do in the denominator, none to do in the numerator. So I'm just going to do the quotient rule, and quotient rule says to subtract. So I'm going to subtract these. And I know 14 minus 6 is 8. So I know it's x to the 8th. Now I have to figure out, let me draw a fraction. Does that x to the 8th, does that go on the numerator or denominator? The numerator or the denominator? Well, I know this goes in the denominator because there are more exponents on the bottom. And since everything canceled out and moved to the bottom, there is an invisible 1 over here. So this answer is 1 over x to the 8th. 1 over x to the 8th. So I like this problem because it reviews product rule, it reviews quotient rule, and so that way we know how to do these. So that's a little bit on number 1 there. Now, today I want to move into, go and draw a line under here. I want to move into negative exponents. Okay, so we're going to do a little discovery. So let's use the number 2 to the 3rd. Go ahead and write 2 to the 2nd. Go ahead and write 2 to the 1. And let's put an equal sign over there on all 3 of those. So 2 to the 3rd, 2 to the 2nd, 2 to the 1. And now math is all about patterns. So if you can find a pattern, it's going to continue on, and you can make new discoveries and make learning about math a little bit easier. So 2 to the 3rd, what does 2 to the 3rd mean? 2 to the 3rd means 2 times 2 times 2. 2 to the 3rd means 2 times 2 times 2. 2 to the 2nd means 2 times 2. And 2 to the 1 just means a 2. There's just 1 2 there. So 2 to the 3rd, if we go back here, 2 to the 3rd means 2 times 2 times 2. Well, I know 2 times 2 is 4, and then 4 times another 2, 4 times another 2 is 8. So this equals 8. 2 to the 3rd equals 8. Now 2 to the 2nd, I know that means 2 times 2. Well, I know what 2 times 2 is. 2 times 2 is 4. So 2 to the 2nd is 4. 2 to the 1 is 2, so there's just a 2 there. Now, again, it's all about patterns. So there's a pattern here that's happening with my exponents. There's a pattern here that's happening with the number of 2's that I have. And there's a pattern here on how the numbers are getting smaller. So take a look. I'll give you a little bit of time. Take a look. Tell me if you see some patterns that are happening here. Okay, good. We should see that there's a pattern here with the exponents. They're getting smaller by 1. So if I continue the pattern, I should have 2 to the 0, because we went from 3, 2, 1, 0. Now, if I continue the pattern, what would be the next exponent? 3, 2, 1, 0. The next one would be 2 to the negative 1. And the next one would be 2 to the -2. Okay, so let's explore what that means. Math's all about patterns. In order to explore, we have to look over here on the far right side. So 8 to 4. How can I go from 8 to 4? I'm going to divide by how much? 8 divided by what is 4? 8 divided by 2. I'm going to divide it by 2. Or cut it in half. Does that work here again? Can I cut 4 in half? I can cut 4 in half. And that equals 2. So 2 to the 0, what does 2 to the 0 make? Well, I'm going to follow the same pattern. I'm going to divide by 2. So the question is, what is 2 divided by 2? 2 divided by 2 is 1. We're going in half each time, in half each time, in half each time, from 8 to 4 to 2. Half of 2 is 1. So this is huge right here. This is a huge discovery in math. Everybody thinks 2 to the 0, anything to the 0 power is 0. No, anything to the 0 power is always going to be 1. So let's write that down. Any number to the 0 power equals 1. Anything, any number to the 0 power equals 1. Any number to the 0 power equals 1. That means 10 to the 0 equals 1. That means 53 to the 0 power equals 1. That means 271 to the 0 power equals 1. Any number to the 0 power equals 1. So 2 to the 0 is 1. Okay, so let's continue on this pattern. Let's continue dividing by 2. So I divided by 2. 8 divided by 2, I got 4. Divided by 2, I got 2. 2 divided by 2 is 1. Question now is, what is 1 divided by 2? Well, 1 divided by 2 is 1 divided by 2. It's 1/2. It's a fraction. So this is 1 over 2. Now we have to divide by 2 again. Now, here's where you might not remember how fractions work, but if I divide by 2, that's like making the denominator twice as much. So in other words, I'm going to have a 1/2 times by another 1/2. I have 2 1/2s now because I'm dividing it by another 2 or times it by a half. Well, a half times a half, multiply straight across. 1 over 2 times 2 is 4. Now the pattern's going to continue on forever. I'm going to divide by another 2. So that should take me 2 to the -3. 2 to the -3 is 1/2 times by 1/2 times by another 1/2. Well, 2 times 2 is 4 times 2 is 8. This is 1/8. Look at these numbers here. This being the middle of like the butterfly kind of. Notice we have 2, 1 over 2. 4, 1 over 4. 8, 1 over 8. None of our answers are negative, but we have negative exponents. So here's a key thing here. A negative, I'm going to write this down, exponent does not mean a negative answer. It means a fraction. A negative exponent does not mean a negative answer. It means a fraction. And in fact, here's how we would write it. 2 to the -3. You know what that equals? 1 over 8. But do you know what 8 equals? 8 up here, look here, here's 8. 8 actually equals 2 to the 3rd. So I know that it actually equals 1 over 2 to the 3rd. Notice how we have the same exponent, but when it's moved to the bottom of the fraction, it becomes positive. it becomes positive. And I'm going to give you an example of what I mean. Number 2 here. Go ahead and write this down. X to the third, y to the negative 2. The rule in math is this. Don't leave negative exponents. Go and write that down. Don't leave negative exponents. Don't leave negative exponents. So we have x to the third, y to the negative 2. Well, I have a negative exponent, and I don't want to leave negative exponents. So here's how I solve this. Here's what I want you to do. Draw a line underneath the problem, because we're going to create a fraction. And in order to turn, circle the base that an exponent that has a negative exponent. In order to make that negative 2 positive, I can't just make it positive. What I'm going to do is I'm going to switch it to the bottom. That x to the third is going to stay there because it's already positive. It doesn't change. So let me draw my fraction line. My x to the positive 3 stays because it's positive. But that y to the negative 2, I moved it to the bottom. So I'm going to write y. But it no longer is negative 2. Once I flip it to the bottom, it becomes positive 2. And now I can box my answer because I have no negative exponents. So to make an exponent positive, we flip the side that it's on. To make an exponent positive, we flip the side of the fraction it is on. To make an exponent positive, we flip the side of the fraction it is on. To make an exponent positive, we flip the side of the exponent it is on. So let's try that again. Number 3. X to the 9th, y to the negative 5, z to the 6th. All right, so that's how the problem's given to you. X to the 9th, y to the negative 5, z to the 6th. So first thing I have to ask myself is, do I have a negative exponent? Yep, let me circle that negative exponent with the base. And let me make a fraction. So that y to the negative 5 has to move to the other side, so that way it becomes positive. So my x to the 9th, that's already positive, it's going to stay. Z to the 6th, that's already positive, that's going to stay. And my y to the negative 5, that has a negative exponent, so I'm going to move that to the bottom. And I'm going to write, instead of y to the negative 5, it now becomes y to the positive 5. So only switching the negative exponents. We are only switching the negative exponents. We are only switching the negative exponents. Let me shrink this here a little bit. So room for a couple more problems. So only switching the negative exponents. Number 4 here. Go ahead and try this one. Z to the negative 8 over, now this one already has a fraction. X to the negative 9, y to the negative 2. First thing I would do if I were you, circle all the negative exponents. Z to the negative 8 is negative. X to the negative 9 is negative. Y to the negative 2 has a negative exponent. These are actually all negative. So here's what we're going to do. Let's do this one at a time. Take that z to the negative 8 on top, and it's going to move to the bottom because it's negative. When I write it on the bottom, it now becomes positive 8. It now becomes positive 8. Now here's the cool part. The ones that are on the bottom, to make them become positive, I'm going to take that x to the negative 9 and I'm going to move that one to the top because it's already on the bottom. So let me move it to the top. And then when I move it to the top, it becomes positive. So x to the negative 9 on the bottom becomes x to the 9 on top. Y to the negative 2 in the denominator. When I move it to the numerator, it becomes positive. So now that's y to the positive 2. Everything becomes positive when I switch the side of the fraction it is on. When I switch the side of the fraction it is on. All right, let's go and try this one, number 5. Last one here. Y to the negative 5, z to the third over x to the 8th. Go ahead and try this one on your own. Circle the term that needs to move. The ones that don't need to move, just keep them right where they are. Keep them right where they are. Go ahead and give this one a try. All right, so first thing I would do after I make my new fraction is circle what needs to move. Well, the only one that has a negative exponent is y to the negative 5. So let me move that to the bottom. Everything else is already positive, so it can stay there. So z to the third on top, already positive, that can stay there. X to the 8th, already positive, so it can stay there. And that y to the negative 5 moved to the bottom, so I'm going to move it here, y, and it becomes positive 5. You know you're done when all your bases are different and all your exponents are positive. Z to the third over x to the 8th, y to the 5th. Good. Our essential question today said, how do I make exponent, I'm making exponent positive? You make an exponent positive by doing what? Look in your notes. It's written in your notes. How do we make an exponent positive? Good. You make an exponent positive by switching the side of the fraction it is on. You make an exponent positive by switching the side of the fraction it is on. Good. Thank you guys for following along, and these will be your notes for today.